In this video, you'll build a complete social app using SwiftUI and Firebase, even if you're a beginner. Create an app user struct. Identifiable, and the purpose of this struct is to enable the credentials of the user to be stored. So the user can log in or register using email and password or using Google login. We also need to import foundation. Be provider, email or provider doesn't exist as yet, we'll create that later. Now on lines 15 that should be .email, not email or provider, .email. The next file we need to create is our auth protocols file. I'll just copy and paste the code from the clipboard. So for this protocol, the view model depends on this protocol, not Firebase. Restored session is called at app launch and it must be safe to run repeatedly. Login includes the actual email password flow and will return a valid user. Registration or register, that will return a fully usable app user to avoid extra fetch calls. And then we have our normal functions such as log in with Google and also log out. We also need to add an enum to our author protocols file. Auth state. Creatable. And then we need to check these conditions. Check in session. So these are the cases we will have in the application. Logged out, case logged in. So for check-in session, this will be at startup. This is the startup state while we determine if a cache Firebase session exists. And then we have logout, which is explicit on authenticated state, which should keep the UI logic deterministic. And also logged in, which is authenticated state that carries the domain user model used across the application. We need to create another protocol. Session storing. Protocol includes the following method signatures, which is user, app user, load user, which should return a user, an app user, and also clear. The save function is used to store minimum user snapshot that's needed for fast app launch, and the load user function is used before Firebase restores its session to avoid UI flickers. And the clear function must be called during the logout to prevent stale sessions within the application. The next file we need to create is our user default session store. So let's create a empty file. Name the file user default session store. Import foundation. The purpose of this file, this class, is to enable users' credentials to be stored on the device, but really we should be using the keychain because the keychain is encrypted. We shouldn't be using user defaults, but because this is a tutorial, I'll just demo the application using user defaults. Private net key, auth user, on lines 11 there's a stable persistent key. Changing this later effectively logs out all the users within Firebase. The next one is our save method. Should we try JSON encoder? Encoding keeps the storage layer decoupled from the model schema. And then we use user defaults to save the actual key. We also need to implement our next method or methods, which includes load user, and that should return nil if there's some error. So on this line, failure is intentionally ignored. Corrupted cache should behave like logged out. And then for the clear method, we use user defaults, standard, remove object for key. In the next episode, we will configure Firebase and Firestore for Google sign-in and for storing images and user profiles. In this tutorial, we'll set up Firebase Firestore and create the collections required for our SwiftUI app. These collections will store the user profiles and images and will later be used alongside Firebase authentication for email, password, and Google sign-in. So let's create our project. I'll just call the project Firebase Social App. Let me do that again. Firebase Social App. Click on continue, and then we can select an account. I just selected any previous account that's already there. The project has now been generated, so we just click on continue. The next thing we need to do is click on add app. Since we're building iOS apps, we click on iOS. Next thing we need to do is to get our Apple bundle ID from my application, from my Xcode project, which is here. And then we just paste it into that field there, and then we click on the register app button, and then we just download our Google services info.plist. And then we drag our plist, which is this file here. It might be downloaded to your downloads folder. On mine is on my desktop, so we drag the plist and we just drop it into our project, and then we just click on finish, and then your Google service info plist will be displayed here. Within our browser, we just click on next, click on next again, and again. To add Firebase SDK to our project, we use the Swift Package Manager. So we click on File, Add Package Dependencies. This is the URL. Just select it. It's already added to my project at the moment, but you just select it. And then after that, the Add Package button should be enabled. Then you just click on Add Package button, and then you just wait for the Firebase Iris SDK Swift Manager packages to be downloaded into your project. So the first collection we'll be creating or adding to Firebase is called our users collection. And the purpose of that collection is to store a list of users, such as the display name, the photo URL, and the last time it was updated at. So we need to select or click on database and storage, and then click on file store. Click on create database, just select standard edition, click on next, I'm in the UK, so I just select Europe, click on next. And then we can just select start in production, or is it start in test? Let's just click on select start in test mode, click on create, and then the database should be created. And you can see it's empty at the moment. So for our database attributes, or for the collection attributes, the first thing we need to do is to name the collection. So let's name it users. Click on next. The next thing we need to do is to add our actual attributes. So we add our default author ID, and then the attribute name will be display name, which will be string data type. We need to add another field called photo URL, which is also string, and also another field which is called updated at, which is timestamp field, and then we need to supply a default. Click on save. As you can see, it created a default record within the users table. To enable sign in with Google, we have to select the security and then click on authentication. Click get started. And then we have two options that we'll be using in this application, which is email, password, and Google sign-in. So we're using both. So for the first one, we just get the first one configured, which is email, password. So the user can sign in with an email or password if they don't want to log in with their Google account. Just enable it. Click on save. And then we just click on the add new provider. So now we're going to enable the Google sign-in. Click on Google. Enable it. We can just update the public facing name of the project to the name of the actual project that we created in Xcode. So if you want to, you can call it, for example, Firebase real-time social app. So this is where you can like rename your project. So I just called it Firebase because I've got one there ready. Social app 2 tester. And then we also need to supply our support email. So just select your support email from the list here. And then afterwards, you just click on save. And then the next thing you'll need to do is to download the latest configuration since we've updated it. Click on done. And then you drag that new configuration file or the updated configuration file to your Xcode project and replace it with the old one. So just drag and drop. And then click on finish. And then within your Google service info file, you need to copy the actual reverse client ID. You need to copy the whole string. And then you need to place it within your URL type. Just place it there. So the next thing we need to do is to get the Swift Manager dependencies files for Google sign-in. So we need to click on File, Add Package Dependencies, and then supply the URL, which is this one here. And then you just click on Add Package. Because at the moment it's already in this project, so it doesn't allow me to re-add it. But you just click on Add Package button that would be enabled in your project. And then when both Swift Package Managers have been added, your project structure will look like this. That includes your dependencies. In the next episode, we'll implement our author service and our auth view model. If your SwiftUI login system logs users out every time the app restarts. Your architecture is wrong. Today I'll show you how to fix that using auth service and a proper auth view model. As you can see, I'm logged in as Iris Insights. I will now restart the application. As you can see, I'm still logged in. Notice the session restored automatically. I didn't have to re-authenticate. The first thing we need to do is to create a new Swift file. This will be our Google sign-in client. Import foundation. Import UI kit. Import Google sign-in. Production app should expose a narrow interface, not the full SDK. Also need to create our sign out method. That should return void. As you can see, it's a simple sign out closure, not a method. Also need to create an extension for the Google sign-in client. It should be extension. We need a valid presenting view controller because Google Sign-in still presents UI kit under the hood. I'll just copy and paste that code. And this is where Google sign-in sheet is actually presented. And never assume token values exist. Production code guards hard here. There's a few things we need to add and change. The first one, we need to include our extension. For the view controller. We also need to fix lines 26. Create a new file called auth error. And then we just paste the enum. So this enum includes the type of errors that the application can handle. So we go back to the Google sign-in client that we're working on. And as you can see, some of the errors, they're starting to disappear now. Lines 33, that's incorrect. It should be results.user access token string. And for the else statement, we don't need a bracket there. Can delete that bracket. And on line 35, we should be throwing a sign-in error, missing tokens. The next thing we need to do is to map the SDK result into a simple app level value. This also keeps the code base cleaner and easier to test. We need to delete the bracket on line 41. Also need to call sign out. So there's an issue with lines 33, so line 33, that should be after line 36. That seems a bit better. Let's compile it. This video is getting a bit long. In the next episode, we will continue the Google related layers and then add our auth service and auth view model. Most SwiftUI login flows breaks when the app restarts. Let's fix that. We need to create a new file. Name the file auth service. Import Firebase auth. Then we need to create a few variables. On lines 12, this is the local persistence. It's treated as a session snapshot, not the source of truth. On lines 14, it's the third party sign-in. It stays behind an abstraction, so this service is testable and also replaceable. This is dependency injection that keeps the auth isolated from the SDK setup. Always trust the live Firebase session over cache state. Cache auth data can drift. The backend identity provider is the only authority. On lines 24, before current, there shouldn't be a full stop. I'll just paste this code from the clipboard. That rehydrates the domain user from Firebase so the app boots from a verified identity state. On line 33, we then refresh the snapshot. And then we return a user. The next function to be created is our login function. I'll just copy and paste it from the clipboard. So we need to create a few more properties. Invalid credentials. Doesn't seem like it exists, or maybe it's not in scope. Let's have a look. Auth error. So let's return to our auth service. We need to update some of the argument signatures. On line 43, we reject obvious bad input early, so we do not spend network time on invalid requests. Firebase auth remains the authentication authority. The service only maps results into an app model. This builds the domain model from the SDK response, not from any pre-auth request payload. As you can see, the map Firebase auth error function does not exist at the moment, so that's the function we need to create next. Private function map Firebase auth error. We need to return error. Let ns equals error as ns error. Firebase exposes failures as ns errors. We only translate known Firebase auth errors, everything else passes through untouched. Now let's compile it. Oh, so there's an issue. Auth service does not conform to protocol. Seems like we're missing a function that we haven't implemented as yet. Let's click on apply. So we're missing a few functions. Let me just move the functions, signatures down to the bottom to make it consistent. Yeah, so we need to implement register. I just copy the code from the clipboard to reduce the length of the video. So this is the function for register that enables the user to register for an account. Similar to what we've done previously, we had some validation. Firebase account creation also authenticates the user, so no registration flows directly into the session setup. Newly created users can still return incomplete metadata, so we need to guard for that. We need to add the code for login with Google, so I'll just copy what's on the clipboard. Update our arguments so that they're in the correct position. The app identity model requires a stable email, so fail before exchanging credentials if metadata is incomplete. The next function we need to implement is our logout function. Google.signout. So the Google.signout, it clears the external provider session first to avoid a silent reauth on the next login attempt. Firebase session is invalidated nets, which removes current user immediately. A local snapshot is cleared last, so stale states cannot survive at relaunch. The next file we need to create is our auth view model. Import SwiftUI, import combined, at main actor, I'll just copy and paste the rest of the publishers and the initializer. That includes our dependency. Store session, so that doesn't exist as yet. Let's create that now. I'll just copy and paste it. The view model acts as the app authentication state machine. Just want to copy and paste the login functionality. Defer guarantees UI loading state is cleared even if async or fails. The view model translates domain errors into UI safe messages. So the rest of these functions will enable register, log in with Google, and log out to be called from the service. In the next episode, we will implement the UIs and also make the state-driven navigation feel like a real app and not a demo. We'll wire author state into navigation so the app behaves like a product. Instant session, restore, loading state, logout, and zero duplicate logic. Within our app file, we need to type the following. What we've done here, we have configured Google sign-in from Firebase client ID. In production, Firebase owns the client ID. Don't hard code it. Don't copy and paste into the plist. This avoids environment drift and could eliminate a whole array of bugs. The next view we need to add is our root view, and then we will return to this file afterwards. So we add a new SwiftUI file. The first launch path. Keep the app in a controlled loading state. In a real app, this avoids messy UI flashing, while persistent auth or token refresh logic is still resolving. We also need to create another view, which is called loading view, but we add that later. And the same goes with our login view as well. We add that later. I'm deliberately unwrapping the associated user here at the root. That gives downstream views ready to use data immediately. We also need to create our main tab view, which we'll implement later. On a pair is needed. The root view is in the correct place to kick off the session bootstrap. One entry point, one auth decision, and predictable navigation. And this is the kind of structure that scales and grows your application. Just compile it. It seems like we need to decorate the cases with empty view so that the file compiles. Empty view. Let me try it again. Empty view. So let's go back into our app file and then apply our root view within this file. Within the Windows group section, just replace it with your root view. and then just passing the auth to the environment object. That's required to enable Google Sign In to return to the app. Now we can create our loading view. I'll just copy and paste the code from the clipboard. Go back into our root view. Now we can comment out the code for our loading view and then delete our empty view. Now we will create our reusable container view, which is app card. Let me just create an empty file instead. View Builder initializer keeps the API flexible, so the card can wrap anything from a simple text view to a full layout without forcing callers to construct the content beforehand. Thin material gives a subtle system blur that adapts automatically to light and dark mode and platform changes, which is generally safer than hard coding background colors. The next view we need to create is banner message. The purpose of this view is just to show any errors to the user or status updates. So we create a new empty file or a new SwiftUI view, it's up to you. Call it banner message. Just import SwiftUI and copy and paste what's on the clipboard. As you can see, this is also another reusable view. The next view we need to create is our main tab view. This will enable the user to navigate within the application. So let's create a new SwiftUI view. I'll just copy and paste some code from the clipboard. I prefer routing logout through the auth view model instead of handling state locally in the tab. That keeps authentication lifecycle decisions centralized. Notice each tab owns its own navigation stack. This avoids navigation state leaking across tabs, which becomes a real problem once each tab starts pushing deeper within the hierarchy. Now we can return to our root view and then apply our main tab view. that we created earlier. It should be user with a lowercase u. I'll just compile it again. The next view we need to create is our login view. I'll just paste some code from the clipboard. We need to include a few private functions. We also need to create another private function for our primary button title. And also for our field. And the secure field. The next thing we need to do is to track which auth path was tapped before calling into the view model. That gives us precise loading feedback and stops the UI from showing the wrong spinner when multiple sign-in options exist. So we need to call our app card. We need to add a VStack, spacing 12. With a button, active action equals dot email. If mode is equal to sign in, auth.login, email, password, else auth.register, email, password, full name. That should be full name. Now we just need to apply the button label caption, which is there. And then we're missing a function called can submit email, which we need to implement. private var can submit as you can see, this is a computed property and not a function. That was my mistake. Can submit email let min equals mode equals dot create 6 4 return email dot contains this isn't full validation, and that's intentional. At view level, I'm only blocking obvious weak submissions. The real validation rule should still live in the auth layer. We next need to give the user the option to sign in. So we need to implement the button so that they can sign in with Google or with their username and password. To reduce the length of the video, I'll just copy and paste the rest and then explain it. I like resetting transient UI state when the async auth cycle ends. It keeps the view honest. Once the request is done, the screen stops, pretending a button is still active source of work. Now we should be able to run the application. I'm just going to check to make sure that everything is in place. The root view, the call login, remove the empty view, now let's run it. Since I'm already logged in, I will be shown my available tab items such as browse, alert and me that will navigate to my profile. But if you haven't logged in as yet, you will be prompted using a few options such as Google login or login with username and password. Let me see if I can reset the simulator to show you how that would look. Let's run the application again. I just reset the simulator. See, as you can see, this is how it should look if you're not logged in. You can log in using Google, as mentioned, and it will come up with that and just continue. Or if you don't have an account, you can create a new account. In the next episode, we'll be able to browse profiles in real time without manually refreshing the application. Before we store our users' profiles in Firestore, we need models that map cleanly to the database and work nicely with SwiftUI. So the first thing we need to do is to create a new file. Let's call this file Profile Models. Import foundation, and I'll just copy the code from the clipboard. We also need to create another struct called Profile Review. Identifiable, codable, equatable, var ID, string, that should be string, var reviewer UID, string. Using the reviewer unique ID as a document ID ensures one review per reviewer. This prevents duplicate reviews and makes updates much more easier. Also need a reviewer's name, which can be optional, var rating, also comment, var created at, which is date. The created at is stored using Firestore server timestamps to guarantee consistent ordering, and that shouldn't be optional. Okay, that's correct now. The next file we need to create is a profile store file. I'll just rename it to Profile Store. We need to import foundation, import Firebase, Firestore. Profile Store is a data access layer responsible for reading and writing user profile data in Firestore. It centralizes real-time listeners, profile updates and review management so the rest of the app can interact with user data through a clean, consistent API. We need to create a class which is called Profile Store. We also need to add a few static shared variables. I'll just copy and paste them. We also need to create a new function that's called observe profile. Firestore Listeners gives you real-time updates for free in production apps. This removes the need for manual refresh logic because the UI can react to back-end changes as they happen. So that's what we'll implement now. Let snapshots. On change. Success. User profile. And the overloaded method that we need is the fourth one that includes the second one that includes the display name. So we pass in the user's ID, and for the display name we just pass in user and then return. And now we have to check to see if the snapshot doesn't exist. If the snapshot does not exist, then we do the following, similar to what we've done above. So I just copy and paste the lines between 28 and 29. For the display name, it will be new user, and everything else stays the same. Get data, snapshot data. If there's no data in the snapshot, we just assign it to our default array elements. That doesn't include anything. Next thing we need to do is to get our URL. Never let missing Firestore fields break your UI model. We need the third overloaded method or function signature, and then for the ID we just pass in our UUID. For the display name we just pass in display name. For the photo URL we just pass in the photo URL. And then we need another ending bracket to end that function. Now let's compile it. The next thing we need to do is to create another function that will observe other profiles within Firestore. So I'll just copy and paste the code from the clipboard and then explain it. So the important thing to explain is line 76. It's small detail, but then it's a big UX win, which sorts once in the store, so every screen gets consistent ordering. And this will also avoid duplicate sorting logic in the view model and keeps the presentation predictable. The next function we need to create is called Upsert Profile. And then the important thing that we do here is that we use merge and assign it to true. Using merge here matters. In production, a profile document usually gains fields over time, and merge protects unrelated data from being overwritten by a narrow update. The next function we need to create is called update photo URL. I'll just copy it from the clipboard. We also need to implement another function called observe reviews. I'll just copy and paste it from the clipboard. As you can see, docs doesn't exist, so we need to create that now, and I'll explain it afterwards. Docs equals snapshot or snap documents. Ordering at the query level keeps the client lightweight. Firestore does the sorting server side, so the UI receives already ordered results instead of sorting larger collections locally. So that will help for performance and a speedier application. The next function we need to create is our upsert review. I'll just copy and paste it from the clipboard and then explain the important parts afterwards. So within our auth errors file, we need to add a new enum. Enum review error localized. Localized error with the following cases: cannot review own profile, invalid rating, var error description, and then I'll just change some of the text to be returned. You cannot review your own profile. Rating must be between 1 and 5. Now let's compile it. Invalid rating, so let's look at that again. I just spelled incorrectly, so that should be invalid rating, and that should be invalid rating. Let's compile it again. So now we can go back to our profile store file. So this document ID that I'm highlighting at the moment, users, is deliberate. So that will enable one review per reviewer. It lets writes safely overwrites the same document, keeps updates simple, and avoids duplicate reviews, which is cleaner code. Now that our file store models are in place, we can actually start using them in the UI. In the next video, we'll build a simple SwiftUI browser screen that loads profiles and lets the user search through them. In this video, we're going to build a user search feature in SwiftUI powered by Firebase. We need to create a new Swift file, which will include our view model, I'll just copy and paste some code from the clipboard. We need to create a function called start. Always remove any existing listener first. With Firebase, duplicate listeners are an easy way to create subtle bugs, duplicated updates, and unnecessary reads. Capture self weakly inside long-lived callbacks. Firestore listeners can outlive the screen that created them, so this avoids keeping the view model alive longer than expected. If the screen is no longer visible, the listener should not still be consuming updates in the background. The next view we need to create is our Browse Profile view. This is our SwiftUI view. I'll just copy and paste some code from the clipboard. Bail out early before filtering. In a real app, I do not want to keep on recalculating unnecessary work when the search box is empty. Normalize once, then filter. These are the small details, but this is exactly the kind of thing that keeps searchable lists feeling more responsive as your data grows. I'll just copy the view body that was deleted earlier. No, that's not it. Just compile it. For names, usernames and IDs, I'll usually turn off autocorrect and auto capitalization. Otherwise, iOS starts helping in places where it is actually unnecessary and also introduces UI or UX issues. that doesn't exist as yet, profile skeleton row. Skeleton rows are not just visual polish, they preserve the layout while data loads. This makes the screen feels faster and more stable than flashy in content later. Then flashing in content later. I'll just paste the view from the clipboard for profile skeleton row. And then compile it again. I'll just copy some code from the clipboard and then type in the rest. Empty state copy should guide the next action. No results alone is a weak UX. Give the user a clear recovery path. Once the list starts growing, lazy VStack is a safer choice over a regular VStack because it avoids building every row up front. This view does not exist at the moment. I'll copy and paste it afterwards. So I'll do that just now. I want the whole card tappable, not just part of it. Wrapping the row in a navigation link gives better hit testing, cleaner accessibility and a much more polished feel. We need to add another closing bracket at the end of this view. And also avatar circle cannot be found, so we need to add that afterwards. So the next thing we need to do is to add a spacer. Task is a better lifecycle hook here than stuffing this into on a pair. It keeps the intent clear. Start the work when the view becomes active. If the view model is listening to live updates, this cleanup matters, otherwise you risk keeping work alive after the screen is gone. So now we just need to copy and paste the avatar circle view. We need to include another fallback. Always design for actual failure paths. Remote images fail more often than people think, so the fail back should still make the UI feel intentional rather than broken. I'll just compile it. The next thing we need to do is to return to our main tab view, our SwiftUI view, to enable our browse profile view to be navigated to. So I just copy the code from the clipboard. Compile it again. And now we can try to run it. And as you can see, we now have a list of users' profiles that we can browse. We can also filter or search. In the next episode, we will implement the profile screen review listeners. You'll ship an actual review system with validation. This episode turns your app from a list of users into a product. Profile page, rating summary, review composer, and live updates. We need to create a new file. We can name the file Storage Manager. And then we just import the following frameworks. We also need to create an extension on the UI image. I just copy it from the clipboard. We also need to make sure that the UI image is always scaled down proportionally and it's never scaled up. So to do that, we need to type in the following. Let's scale equals min max size width divided by width max size height divided by height, comma 1. We also need to add an enum. I just copy it from the clipboard. We also need to add a store manager class, and then we need to implement the rest. In production, I always resize before uploads. If you send raw camera image, often between 2 to 5 megabytes, you'll slow the upload, which also hurts UX on mobile data and quietly increases your Firebase storage and bandwidth costs. So the solution is to type the following to resize the image. 0.8 is intentional, higher-weighted bytes with no visible improvement, lower noticeable compression artifacts, especially on retainer displays. This is one of those things people skip early on. If content type isn't set, you can run into subtle bugs later. Broken previews, incorrect caching, or issues with web client consume the image. Upload first, then fetch URL from the same resource. Avoid generating or storing URLs prematurely. Keep the flow deterministic. The next file we need to create is our profile view model. I'll just copy from the clipboard. One of the easiest ways to create hard to track UI bugs with Firestore is to attach multiple listeners for the same screen lifecycle. It might look fine at first, but once users navigate back and forth, duplicate streams start stacking and your state update stops feeling deterministic. We need to add this new function. And then just type the following code. I want the view model to be a single UI facing source of truth here. The moment the view starts owning transformation logic for real-time data, the screen gets harder to reason about, harder to test, and easier to break during refactoring. Also, this is fine for a smaller review feed, but if this collection grows, you probably want query, limits, or pagination. Real-time listeners are great, but you still need to think about the real read costs and scaling. We also need to add this other function, stop listening. We also need to add the upload avatar function. I'll just copy it from the clipboard and then type in the rest. And it should be store manager. I mean storage manager, not store manager. I prefer splitting the file upload from the document update instead of hiding both inside one call. It gives you cleaner failure boundaries, better login, and much better visibility. When storage succeeds, but the profile write fails, which is absolutely does happen in real apps. We also need to add another function called save display name. And then type the following. Also type we also need to add this computed property and then type in the following. Tiny detail but worth keeping defensive logic here. If bad data ever lands in Firestore, I'd rather clamp the calculation than let the mail form document distort the UI. The next file we need to create is our profile view. So we can either create a new empty file or a SwiftUI file. I'll just create a new empty file. Just rename it as profile view. And I'll just copy and paste from the clipboard. These views, they don't exist at the moment. We'll create them later. Just type the following. I like kicking off the profile and review listeners from the screen entry point because the view stays declarative while the view model owns the real-time life cycle. This validation matters more than it looks. Without it, incoming real-time updates can keep stomping on local editing state, which is exactly the sort of subtle UX bug that makes the form feel unreliable. We also need a hero header. I'll just copy and paste it. We also need a rating summary view. Just need to type the following. I prefer deriving the summary directly from the reviews collection. As soon as you start storing duplicate rating state in multiple places, drift creeps in and the UI becomes harder to trust. It's a small thing, but this icon helps the card read faster without adding more text. On content heavy screens, visual compression like this keeps the UI feeling cleaner. This video is quite long now, so we need to implement the other features of the UI in the next tutorial. The next view we need to create is our owner edit card. But the purpose of the owner edit card view is to enable the user to edit their profile photo and also to edit their actual profile. So we need to add a closing bracket, and then I'll just copy and paste the code from the clipboard. Within our onChange event, we need to type the following: task await load picked image. This function doesn't exist at the moment, so we just load the selected picked image that we're passing in. I prefer loading the picked image as a separate step before uploading. It gives the UI a clear local state boundary and makes it much easier to support previews, validation, compression, or image editing later. The next view we need to create is the review composer card. The purpose of this view is to enable the user to post a review. I'll just copy and paste the code from the clipboard. Submit review doesn't exist at the moment within our view model, so we'll be implementing that in our next episode. So the first thing we need to do within the review composer card is to type the following: start picker rating. And then for the binding, we just pass in a review ratings. Start picker doesn't exist at the moment, but we'll be creating it in a few minutes. I like isolating the rating interaction into its own tiny component. It keeps the composer readable, and it also stops the screen from turning into one oversized body block. Next thing we need to add is to clear the review text. I only clear the field after the async submission returns. Clearing too early makes the UI feel fast in demos, but in production it can hide failed writes and confuse the user about what actually got saved. The next view we need to create is the review list card. I'll just copy and paste it from the clipboard. And then type the following. This tiny bit of text makes the app more easier to understand. Next thing we need to do is to loop through our reviews. And then we need to pass each of the reviews to another UI component or view. So that should be review row. This one doesn't exist at the moment. We'll create that afterwards. For a lighter feed, this is fine, but if the reviews becomes larger or highly active, this is one of the first places I'd revisit and move towards lazy rendering or pagination. The next thing we need to add is a function called load picked image. We can delete that unwanted bracket on line 384 and then type the following: selected UI image equals to UI image. The code in here keeps failure close to the source. If the image conversion breaks, I'd rather fail before the upload path starts, not halfway through storage logic, where the error becomes much noisier to debug. So we just paste our review row view. Initial avatar doesn't exist at the moment. We implement that in a few minutes. And also the star row doesn't exist at the moment. Type the following: text, review, created app, Relative dates are a nice UI win here because they feel more human than raw timestamps. I'll now copy and paste the initial avatar view. Really, these views could be in their own file, single file. Just type the following now. Fallback avatar matters more than people think. A screen still needs to look intentional even when remote image data is missing or delayed. The next view we will add is our star row view. I'll just copy and paste it from the clipboard. And then type the following within the loop: image, system name. Clamping here keeps the UI defensive. If bad data slips through upstream, I still want the visual output to stay stable. I'll just copy and paste the star picker view. Yeah, so we need to navigate to our browse profile view. And then I think it's on line 93. We need to add the code to enable our profile view to be navigated to. So we delete the content view line on lines 85 and type the following. We pass in the ID. We also need to make the following changes within our main tab view. So let's locate the main tab view, and it should be on lines 41 or near line 41. We just need to delete the empty view, so it's on line 38, and type in the following: profile view, select the second overload, user ID, and then user.fullname. Now let's compile it and see if it works or not. So this is what you should have so far. As you can see, if I select any user, can navigate to the profile of the user, see the reviews, write a comment. At the moment I'm logged in as Fred Blogs, so this is my profile and the comments received. In the next episode, we'll be implementing some of the alerts and notification features of the application. Notifications are the retention engine. When someone reviews you, your app should feel reactive. We'll build a real-time notification feed with unread count and deep links. But before doing that, we need to add a function that I've forgotten to add in the previous tutorial, and that function needs to be called within the profile view on the onChange method. So the function is, we have to use task as it's asynchronous, but the actual function is load picked images, or load picked image, and we pass in the image, which is the new item. And now I will run the application. Oh yeah, the reason why I've done it that way is because I prefer loading the pick image as a separate step before uploading. It gives the UI a clear local state boundary and makes it much easier to support previews, validation, compression, or image editing later. I'll just run the application now to show you how it should look. Here's the application. At the moment, I'm logged in as Fred Blogs. So if I wanted to change my image, my profile image, all I need to do is click on choose profile photo. I just change it to anything. I change it to this one. so we can notice the difference, and then click on upload avatar. As you can see, it's been refreshed and updated, and that was the feature that was missing in the previous tutorial. So now we will continue with the notification section of this episode. So what we need to do now is to create a new file called notification model and store. I'll just copy and paste some code from the clipboard. The next thing we need to do is to create the following class, which is called notification store. That should be class, not function. And then I'll just copy the following from the clipboard. The next thing I'll do is to create a new function called observe notification. And then I'll paste some more code from the clipboard that includes the collections, and then type in the rest. I always push ordering into Firestore rather than sorting after the fetch. If you sort on the client while live updates are coming in, you can get jumpy UI, inconsistent ordering, and extra work every time the snapshot changes. So what do I need to do now? I'll just copy some more codes from the clipboard and then type the rest and then explain it. And the reason why I do it this way is to reduce the length of the videos. Notification payloads tend to involve IMAP defensively so that the imperfect document doesn't take down the whole screen. In production, keeping the feed usable is usually more important than failing hard because one field came back missing. We also need to apply our onChange event. What else do we need? I think we need another closing bracket. I think there's an error somewhere. What it is, line 68, that should be moved to line 69. Let's try it, compile it again. The next function we need to add is mark red, and the purpose of this function is to update the status of the notifications. So what I need to type in now is set data is red, merge is true. This is a patch, not a rewrite. Using merge here avoids accidentally wiping fields if this document grows later, which is exactly the kind of bug that slips into like the actual code base, normally after iterations on the schema. The next function we need to create is the onRedCount function. The purpose of that function, it just displays the notifications that have been or that haven't been open, that are still closed. So we need to type in the following: where field so that should be is red is equal to false. And then we add the snapshot listener. I prefer a dedicated onRed listener instead of deriving this from whatever the list is doing. Once the different screens start filtering, pagination or limiting results, badge counts drift unless they are backed by their own query. So the next function we need to add, I'll just copy it from the clipboard, is the delete notification function. And then the next function is the create notification function. I'll just copy some of that from the clipboard and then type the rest. Just making sure this is correct. Title, body, type the URL value is red, which is false. Created at. So created at should be field value server timestamp. Any as any as any, and then we also need to include the merge to be true, and we need another closing bracket. Any is spelled incorrectly on lines 135. I'll just compile it. Now, in the next episode, we're wiring this into real user actions such as follows, likes, and live activity. This is where your app starts behaving like a real social platform. Don't miss it. I'll see you in the next one. Most SwiftUI notification screens break with real-time file store. Here's how to build it properly. The first thing we need to do is to create a new file, which will be our view model. Name the file as notification or notifications view model, and then I'll just copy and paste some code from the clipboard. The stop method on lines 22 doesn't exist at the moment, but we need to type in the following, which is task at main actor and then we also need a case for the failure to capture any error messages. Even though this view model is at main actor, I still hop back explicitly here because Firestore listeners are callback based. I don't like assuming which thread a backend callback arrives on when using publish. I'll just copy and paste some more code to the clipboard and then type in the rest. similar to what we just done previously. Task at main actor. We also need to append a closing bracket and also another closing bracket there. So the next function we need to create is, I didn't explain about this block of code, so let me explain now. I keep onRead count on its own listener rather than deriving it from items. Once the main list gets filtered, limited or paginated, derived badge counts become unreliable very quickly. And that's what I've experienced in the past. So now we need to create our stop function. Function stop. Listener, just remove our listener. Real-time listeners need explicit cleanup. If you forget this, it's very easy to end up with duplicate listeners, duplicate UI updates, and the kind of bugs that only show up after navigating back and forth a few times. So I'll just copy and paste the remaining code for this view model. I'll just compile it. The next file we need to create is our notification view. The purpose of this file is to show a list of notifications that have been retrieved from Firestore. So let's create that new file now, SwiftUI file. I'll just call it notifications view, and then I'll just copy the code from the clipboard. Oh yeah, also I need to import SwiftUI. Make sure everything is compilable. And then the next thing is to implement the rest of the code for this view and then explain it. So the first thing we need to do is type in the following codes. for lines 42. Relative time is a small UX win, but it matters more than it looks. Absolute timestamps makes things feel stale quickly, whereas this method is better when performing live updates. Now we need to navigate to .onApair and type in the following. And it should be is red, if not red. Marking as read on a pair is simple, but it's not free. In fast scrolling scenarios, this can trigger multiple writes very quickly. In production environment, you usually use debounce or batch this to avoid unnecessary loads. So the next thing we need to do is to navigate to lines 80, anywhere after line 78 anyway, and then type in the following. Starting listeners in task keeps it tied to the view lifecycle. If you trigger this multiple or trigger it in multiple places without stopping, you'll end up with duplicate listeners and duplicated UI updates, which is a classic real-time bug. And now we will just stop the listener, as what I mentioned earlier. So what this is really, this is an explicit teardown, which matters when using Firebase or Firestore listeners. If this doesn't run reliably, you'll leak listeners and your app will feel haunted, with updates coming from screens that are no longer visible. The next thing we need to do is to open our main tab view that we created a few episodes ago. And then we need to create a new instance of our notifications view using @stateObject. I'll create a new instance of our notifications view model. I think there's an S missing. And then we need to add some code after the tab item of our alerts. So we just use dot badge if. So that should be notify VM on red count more than 0. A red count. So the badge if extension doesn't exist, so I just copy and paste it from the clipboard to reduce the length of the video. And then after line 65, just type in the following. Now I mean after line 66, not 65. So let's task. And then we pass in the ID so that we get the correct notifications of the user. And then when the view will disappear, then we make sure that we stop the notifications. Now let's compile it again. If this tutorial has helped you, please comment, like and subscribe. And see you next week.